Hello, my name is Julian Hartwell, and my partner was Juliana Zhou, and we were Team 8. Our data set was Kaggle New Jersey train delay data, and we chose specifically to develop a prediction model for New Jersey Transit station delays. Our team was contracted by New Jersey Transit to help improve their train delays and highlight specific problem stations in need of improvement. Why is this a problem? Well, delays affect the bottom line. Riders get frustrated and look for other options like carpooling. Delays accumulate over the course of the day, so it's important to handle potential delays quickly and efficiently. As shown in the graph on the left, there are longer delays during the evening rush hour. However, both rush hours cause a spike in delay times. Our project was to develop a user-friendly dashboard for New Jersey Transit. The app that is shown here in this mock-up will allow users to plug in factors like date, time, and weather to get a delay score by station. This would be for internal use only. It's not practical to broadcast predicted train delays to customers. So who would be the users of this dashboard? The app was designed with New Jersey Transit executives and directors of operations in mind. New Jersey Transit has limited resources and needs a way to allocate station and track improvement resources efficiently. Our goal was to make a dashboard easily usable by non-technical decision makers. Now let's look at what's causing these delays. Many stations have overlapping rail lines, as you can see in this cluster just west of Manhattan, which can contribute to compounding delays across stations. We looked specifically at 11 New Jersey Transit lines. This excluded Amtrak, PATCO, PATH, and SEPTA. Another issue for us was the age of New Jersey Transit's rolling stock. Some are over 20 plus years old, and the oldest from 1968 is still in circulation. To give you some perspective, that was the time of the last civil rights movement and the Apollo missions. Until New Jersey Transit gets a new shipment of trains in 2022, it's important to minimize breakdowns of current stock. We know from existing data that the average delay across each station is 5 minutes. However, when looking at all 150 stations of New Jersey Transit, we clearly have certain problem stations. Trains originating at or destined for Atlantic City had significantly higher average delays, so we decided to delve deeper. We looked at the top 10 most delayed stations on average across all New Jersey Transit stations. The Atlantic City line saw significantly longer average delays of over 10 minutes on average. These are shown in the blue bars here. This example shows that delays are cumulative and impact the entire rail line. It's not just one stop. However, beyond problem stations, variable factors like weather also play a large role in delays. Our results found that snowy conditions are associated with 3 times longer average delays than not snowy ones. Interestingly, there is very little difference among other weather conditions. We clearly have a snow problem, not a temperature problem, as you can see in the graph on the top right. Based on these initial analyses, we built 3 predictive models using relevant combinations of features. Model 3, which will be used for our dashboard at the bottom here, included calendar and snow features, as well as distance to various high traffic hubs, which we know are important. Our models were about 2.3 minutes off per station, which was a 44% error. These charts here show the relationship between our predicted delays along the x-axis and actual delays on the y-axis. When looking at delays, there's a clear bimodal distribution here. We found that we were under-predicting small delays, but over-predicting large delays. There were also several instances of large delays, but on a normal day, it's hard to predict which stations are going to exhibit that. In conclusion, there are missing features that we wish we could have accounted for to make our dashboard a little bit better. Bridge features may have helped explain delays between 2 stations, while ridership impacts also could impact delays, especially during rush hour or snowy days. But ultimately, we were limited by our data set as well as other open source data. We hope that this dashboard will help us in determining station improvements going forward. Thank you.